So in this video, I'm still working on the wish list for Sudoku, and I'm at find blank. Let's see, what was it supposed to do? It consumes a board and it produces a pause. And it's supposed to produce the position of the first blank square. And it's allowed to assume the board has at least one blank square. So here we go, let's do some examples. Let's see, check, expect, find blank. Now what was that board that's totally blank? Oh, that's board 1. Board 1 is totally blank. I'm down here at find blank. So if I call find blank on board 1, then the first blank position is 0, the position of the first cell. And let's see, check, expect, find blank. And if I say cons, I don't know, it doesn't matter really, 2 into rest of board 1. So that's a board that only has its upper left full. Then that's supposed to produce 1. That's probably enough examples. Well, I guess this is a list. I should have one 2 deep, really? Should I? I guess, I don't know. Let's try it. Check, expect, find blank. Cons 2, cons 4, rest of board 1. So that's a board that starts out with a 2 and a 4, and then the whole rest is empty. And then in that case, the first blank is at position 2. So that's my examples. Let's see, how are we going to template this? To find blank. Well, it consumes a board, and it seems like it's kind of got to work its way through the board. Yeah, so let's see, that template's according to board, and board, of course, is just a list of pos or val. So this is the list of template. Empty board, ... And quickly remind myself what board is a list of. Board is a list of either val or false. So back down here. Something first of board. And this is going to be either val or false. Rest of board. Let's see, rest of board is, of course, the rest of the board. So this is still under the list. So this is a natural recursion here. Find blank rest of board. Now let's see. This case isn't supposed to happen. We've got an assumption that the board has at least one blank square. So we're never supposed to run out of board before we find a blank. So this isn't supposed to happen. We could treat this, a number of different ways. We could just return 0 or something like that. I'll show you something that you haven't seen yet before in this course. It's not really a learning goal for this part of the course, but I'll just show it to you quickly. There is a thing called error that lets you say the board didn't have a blank space. And what that will do is it will cause an error of the kind of errors that you're used to seeing. It's giving exactly that message. So you might want to do that in this case. Let's worry about the case we're really supposed to worry about. Let's see, now why is it that this board has a blank in it? Why does it have a blank at position 0? Well, it has a blank at position 0 because the first element of the list is false. And in other cases, we have to keep going. So let's see. If the first of the board is false, then that means the position we're at right now is a blank, so let's produce 0. Now otherwise we're going to do the natural recursion. Let's see, that means we'll take the rest of the board and we'll go find a blank position relative to the rest of the board. And that's key, it's relative to the rest of the board. So because it's relative to the rest of the board, what we're going to do with that is we're going to add 1 to it. And so that will find a value in the rest of the board. Let's try that. This name was previously defined. Oh yeah, this is the usual. I forgot to comment out the stub problem. Let's run it. And let's see, some tests are failing. We need to see whether any of these are tests on find blank. And let's see, that one isn't. It's these tests on solve. You know what I'm going to do here at this point? These tests are going to keep failing for a while until the wish list is done. I've got them, I've validated them, they have a good, they're well formed. At this point, I'm going to comment them out. And what I'll do is I'll put a little note here, bang, bang, bang. I'll put it on this line, bang, 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 to remind me that they're still commented out. And now those tests will stop failing and it'll be easier for us to test other things. Let's run it again. Now only one test is failing, and which one is that? Oh, it's the next board's test. So find blank, the 3 tests we have for find blank are working properly, and we never got to the error condition. That's why that line of code is highlighted in black. So there we go, that's find blank. Now I'm going to do fill with 1 to 9. Let's see, fill with 1 to 9 consumes a position and a board, and it produces a list of boards. Oh right, it has to produce 9 boards where the blank is filled with 1 to 9. So for example, let's do an example. If we say check, expect, oh my goodness, this is going to be long. Check, expect, fill with 1 to 9. It's even hard to type. Fill with 1 to 9 of, let's just say, position 0 and board 1. What are we going to get back? Well, we're going to get back list, cons 1, rest of board 1, cons 2, rest of board 1, and so on, right? All the way, there's going to be 9 of them. Let's see, 3, 4, 5, 6, 7, 8, 9. If you wanted to, rather than write that out, you could actually write the expected answer with build list, or you can write it out if you find it more clear. All right, let's make sure our test is well formed. It is well formed. Now let's see, how are we going to template this? Well, we need to fill with 1 to 9, and it's a board we need to fill. We have to produce 9 results. And the 9 results come from the 1 to 9. So we don't really want to template this according to board, because if we template it according to board, that's going to get us to a certain position in the board, and that'll be it. In fact, there's a couple good ways to template this, but one nice way to template it is with build list. So I'm going to template it that way. We need to fill the blank position with 1 to 9. We need to build 9 boards. So we need to say build list 9 of something. Because this build list is going to build us 9 boards. Now let's see. We need to give build list a function. Build list is going to call this function 9 times with the numbers 0, 1, 2, 3, all the way up through 8. And that function needs to make a new board. It's based on this board, and at this position, it'll put 1 plus the number build list gives it. So because that function is going to need access to both of these parameters of the enclosing function, it needs to be a closure. We need to define it with local. So this will be called build 1, and it's going to get a number from 0 through 8 as its argument. And what does it has to do? Well, it has to build a new board with 1 plus this number at position P. There is a function, you might have forgotten it in all this time, but there's a function called fill square that does exactly that. It consumes a board, a position, and a value, and it produces a new board with that value at that position. So jumping back now to fill with 1 to 9 and to build one in particular, it's fill square. It consumes a board, which is that board, a position, which is that position, and now n is going to be 0 through 8. But in Sudoku, the values that we draw, the people who designed Sudoku weren't computer scientists because they counted from 1 to 9 rather than counting from 0 to 8 the way crazy computer scientists count. So this is going to be plus n and 1 because we're going to be called with numbers from 0 through 8, but we actually want to make boards that have values from 1 through 9, so we just add 1. And let's see, that's what we want to call build list with. Let's try that. Oh, I keep forgetting to comment out the stubs today. One of the 11 tests fail. Hey, that's good because I think one was already failing, wasn't it? That's this test failed. That's not this one. Great. Our test for fill with 1 to 9 is working. So our test for find blank is working. Our test with fill with 1 to 9 is working. That only leaves keep only valid. If we did keep only valid, I think next boards would work. I think right now if we do a search for bang, 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 we don't need that, and we do a command U, let's see, there's a bang, bang, bang there. Oh, that's because in the end we need to uncomment those solve tests. And there's a bang, bang, bang there. Hey, we're getting close to the end of this thing. Unless, of course, doing keep only valid causes us to make some more wishes. Okay, let's work on keep only valid. It consumes list of board and produces list of board, and it's supposed to produce a list containing only the valid boards. So let's see. Check, expect, keep only valid. Hey, this is a filtering function, right? We're given a list of boards, some of which are valid and some of which are not valid. We need to keep only the valid ones. That's a filtering function. So I know already that I'm going to template this to call filter. So I'm just going to have one test. I'll say list, and let's see, I'll make an invalid board, cons 1, cons 2, rest of board 1. So that's a board that has two, not cons 1, cons 2, that's a valid board. Cons 1, cons 1. So that's a board that has 2 1s right away in the first row. That one's a loser for sure. And we'll just have that as the only thing, and the result of that is, of course, empty. You're told to keep only the valid boards. You only got a list with one invalid board. That's empty. Remember, because I know I'm calling filter, the test for keep only valid really needs to make sure, did it pass an appropriate predicate to keep only valid? So I'll quickly template keep only valid. That's filter something, LOBD. Let's see, what's the something? Well, the something has to be a predicate that consumes a board and produces true if it should stay in the list. It's got to be some function. It doesn't have to be a closure because it doesn't have to see the LOBD argument. So I'll just wish for it as a new top-level function. It'll be a predicate called valid board, And now let's do the wish list entry. Let's see, this consumes a board and it produces a Boolean. Produce true if board is valid, false otherwise. Valid means no unit contains a duplicate value. Let me see if I could say that a bit better. No unit on the board has the same value twice. So now let's squeeze that into our rule. Produce true if no unit on the board has the same value twice. False otherwise. There's an example of where working to collapse the purpose helps me start to figure out exactly what this function has to do. Bang, bang, bang. Oh, let's get rid of this. And we'll get rid of this over here too. Define valid board question mark. Board, false. And now let's do some tests. Well, let's see. Board 1, which is all empty, is valid for sure. And all those boards at the top that actually work are valid. So all the way down through 5. Now, right now, I'm not generating tests based on any theory of how this function is going to work. I'm just generating tests because I have some examples lying around. And so I know all of those are valid, so I'm going to throw those at this. Because this seems like a complicated function to me right now. I don't quite understand it. So I'm writing down some examples that I have. And let me also write down some examples that I know are troublesome. Let's go look at board 2, I think is a good one. Board 2 has this row in it. So if we take board 2 and we replace the 1 at the beginning, what we've done there is, oops, I missed a question mark in all of these. What this does is it takes board 2 and it strips off the first value, the upper left cell, and now we're putting a 2 there. Okay, I could do that with fill square, of course. It's just a bit simpler to do it this way. So that board's not valid because now it's going to have 2 2s. So that's false. Let's do another example. Valid board question mark cons 2. Board 3 is the one that just has that column down the left. There's board 3. And so now I've replaced the 1 in the upper left corner with a 2. And of course that makes the board invalid because it has 2 2s in that column. There's 2 2s in the first column. There's also 2 2s in the first box. So that board's invalid. And let's see if we can do another one. Check, expect, valid board question mark. Let's go look for another example up here in our boards. See, what can we do with board 4? Board 4 is a bit more interesting, isn't it? If we change that 7 to a 6, then we'll have 2 6s in the first box. So that would be an invalid board. So let's try that. We'll take board 4, and we need the second position, position 1 there, to be a 6. So now we will use fill square because it's a bit easier. Fill square board 4 position 1 is going to be a 6, and that's got to be false. Let's see if all of these are well formed. They are well formed, but most of them are failing. The first one's failing, I guess, because the stub always produces, or the last one of these three are passing because the stub always produces false. Those 5 are failing, and we have an earlier test that's also failing. So let's see. Now, how are we going to template this function? Well, right here, I'm going to stop this video and leave you to work on this one for a bit. It's a little bit complicated, but I suggest you really work on it systematically and remember what the purpose statement says. We need to check all of the units, and we have this constant called units. We need to check that for all of the units on the board, no unit has the same value twice. Paradoxically, this is actually the hardest function to write in this program. The solve function, which was the most interesting function, wasn't really the hardest function to write. And this function isn't that hard either if you just work systematically. There's lots of ways to do it, but I'll just let you know that I have what I think is a pretty nice solution. It ends up using both and map. So I'll stop this video here now.